In the previous lessons, we have already seen when a PN junction is formed, there's a built-in potential across the junction, and also we'll get a depletion region across the junction. In this lesson, we are going to see how to compute the values of this built-in potential and depletion width. The built-in potential we can calculate using this equation. And from here, we can see that the built-in potential is dependent on the ND, which is the donor concentration, and Na is the acceptor concentration, as well as the temperature. For the depletion width, it's the sum of the depletion width in the N type. So this one is Xn, the length here. Okay, it's given here. And Xp is this length. Here to here is Xp. So Xn plus Xp is the total depletion width. And both Xn and Xp are basically dependent on the donor concentration on the N type and P type, Na and D, as well as the built-in potential. Okay, also we have this epsilon Si. This one, the epsilon Si, is basically the permittivity of silicon, okay, and it's given by this value. It's just a constant. Okay, and for the total depletion width, we can sum and simplify. And we'll get an equation like this. One more thing to notice, the Xn and Xp are related by this equation. And from this equation, if we analyze it, we'll find that it simply shows that when the donor concentration is larger, depletion width is smaller. Okay, for example, if we look at this diagram, here we have a larger depletion width, which means the donor concentration is lower. Here the depletion width is smaller, which means the donor concentration is larger. Okay, so that's what is shown by this equation. Okay, now the next thing is, how do we get these equations? Okay, these equations are obtained by using some assumptions, and that assumption is the depletion approximation. Okay, and you can read through this to understand what are the assumptions we made. That's all. Thank you.